Let's talk about callbacks. Does anyone know what a callback is?
It's a parameter for a function to run another function.
I like that. It's a parameter of a function to run another function. I think it's a pretty accurate description. How will we call that function that is a parameter of another function? Correct. It's a type of higher order function. You remember higher order functions when they run as arguments? Yeah? So a callback is a higher order function running as an argument. So, and then the question is, why do we care about callbacks? What's the purpose of having callbacks? Simultaneously, right? Yeah, that could be a good approach. So callbacks try to solve the problem of running concurrent code, yeah, or asynchronous code. Let's show an example. So if I have a function, do stuff. The purpose of the function is not that relevant. So I'll invoke the function, yeah. And the thing is, my function do stuff. If it return hello, yeah. If I want to capture the value that do stuff returns, that's pretty obvious, right? It's pretty obvious that will return hello. Fair enough, no problem at all. However, what happens if in reality my do stuff function takes 1 second to generate that message? Imagine that we go to the backend, yeah? Task 23, task 24, some of you are dealing with that. It takes a while to fetch the data from the backend. Imagine that you are dealing with a database that is in India. It takes a while to get the data, right? It's not immediate. Because of that, let's simulate that. Set timeout. And then after half a second, then what? Can I do that? Return hello? Doesn't make any sense? So will hello message get printed at the bottom? Let's have a look. No, doesn't work. No, I don't want to listen that word today. Next Friday, we'll talk about await, yeah? So I'm talking about classic JavaScript at the moment. So in classic JavaScript, this doesn't work. And someone may say, do you need to return the set timeout? Yeah, because you are not returning anything, yeah? What is that function returning? Nothing. Function doesn't return anything. So that return is the return statement of the set timeout, but the function itself, I hope you agree, it doesn't return anything.
Maybe we should put set timeout and do stuff.
Set timeout?
You can use, for example, set timeout like an argument for do stuff.
Like an argument?
And then return the. No?
Can you auto-call your set timeout function and return it as well?
Auto-call, what do you mean auto-call set?
So return set timeout
Return set timeout?
and also auto-call it. So,
Auto-call, what auto-call means?
so at the end of set timeout,
Yeah,
just invoke it one more time.
here?
Yes,
You want to use parentheses?
yes.
No, that doesn't make sense. That doesn't make sense because set timeout is going to be invoked.
So you're going to return function now.
That's the thing. So what will do stuff return now? Let's have a look. Ooh, 4. 4. What the hell? What that means? And if we run it again, 5. What the hell? What's going on? It's not definitely what we wanted. So set timeout returns an ID. Yeah, it's not what we want. In other words, it's not that simple to capture values that are returned asynchronously after half a second, after 1 minute, after 2 hours. It's not that simple. That's why callbacks exist. Because with a callback, we can do something. We can pass an argument, which is a higher order function, an HOF. Let's call it callback function for now. Why? Because now look, instead of returning hello, we can do that. What that means? That means that take your time. I don't mind how long that algorithm takes. And once it's over, once you've managed to calculate the return statement, invoke my callback function, my higher order function. So then here, as some of you are already smelling, you can do that. How do we display the return value? How do we display hello? Correct. Walter is right. We need to pass an argument, let's call it result or whatever, so then we can display it. So now let's evaluate that again. We don't need to set the return statement on the same timeout. So let's run the example again. It returns undefined, but after half a second, let me change it to 2 seconds. 2 seconds, right? 2000 milliseconds. Do you agree? 2 seconds is the same as 2000 milliseconds? Thank you. So look, undefined, 1, 2, boom. Yeah? That's the way you deal with asynchronous code. And that's the way JavaScript has been working since 1995 until today, to be honest. But at least that was the only way, the only approach towards managing asynchronous code until 2015. And so for pretty much 20 years, which is a long time. So callback functions. Let's try to complicate the example a bit more. Let's try to orchestrate multiple functions doing asynchronous code. Imagine that we have 3 functions, do stuff 1. I'll change that just for readability purposes. Yeah. So do stuff 1 returns hello after 2 seconds. And then we got do stuff 2 that returns codery after 1 second. So if we display do stuff 1, the return value is the return value of do stuff 1 is, and then we do stuff 2 underneath, and here we return the result value of do stuff 2 is result. So now the question is breakpoints, right? Can anyone tell me the execution order of the breakpoints? Bilius?
Yeah, I'll say like, okay, it starts with 10.
10?
Let's say 10. Okay, after
Time out.
step 1.
Say it again.
After number 3.
10, free.
10, 3.
Time out, Bilius. Please think on the solution before participating. Thank you very much. Next one. Nico.
Let's say 10, 3, 11.
10, free, 11.
14, 7, 15.
14, 7, 15.
I agree with Nico because I think
Nico and Sule.
until do stuff 1 doesn't finish,
Yep.
even though the do stuff 2 it takes less time.
Yep.
Until do stuff 1 is not completed, it's not going to execute do stuff 2.
All right. Anyone else?
I can have go.
Yeah, book it. 14, 7, 14, 7, 15. That's it? All right, that's a bit exotic. Anyone else? Did I say there are 3 points on the word challenge? Maybe not, right? You don't care about the points, right? Who? Did I say 3.5?
I think.
Walter! Walter, what do you offer today?
Okay, I think it's gonna be 10.
Yeah?
Then it's gonna be 3.
Yeah?
Then it's gonna be 14.
Yeah?
Then it's gonna be 7.
Yeah?
Then it's gonna be 15. And then it's gonna be 11.
We agree with one.
So Walter, Lucia, Wendy, and Vivian. Ooh, interesting. Can you explain, Walter, Lucia, Wendy, or Vivian, why, for instance, Nico and Sule are wrong?
I think that he's waiting for the timer.
When you start with 10, you go to the actual function and you realize that it can't run it. So then you will go to the next function, 14, so then it can run that. But then you remember that we haven't run the other function, so go back to run that one afterwards.
Yeah.
Without going up.
Yeah. So these guys are right. The guys at the bottom. Yeah. That's the correct order. And I'm very happy that at least some of you managed to identify the flow. So why Nico and Sule are wrong? Even though I agree on the first part, 10 and 3, we start at 10, right? I don't really understand why Bucket thinks we start at 14. Why 14 and not 10, Bucket?
This is not function. I thought it would run last.
No, wait. We're invoking the function, do stuff 1. We have no idea what happened inside of do stuff 1. The first thing is we invoke the function. And then we'll see how long it takes to resolve the function. But the first thing is we need to invoke the function. Yeah? So it follows a sequential order. So the first function to run is do stuff 1, that's for sure. So the first will be 10. Then, because this callback is asynchronous, yeah, it may take a while to process that line 11. That's why it will jump straight to line number 14. Sorry, excuse me. After 10, we go to the do stuff 1, which is here, yeah, and then we say, okay, I need to run that line. So next line is line number 3. But then, because this is asynchronous, that callback won't run until 2 very long seconds. We continue farther down. So the next line is line number 14, which is the same principle. Do stuff 2, 14, and then that means that now we go to line number 7, do stuff 2, and again, it will take 1 second to complete. Yeah? So the first 4 elements are pretty obvious to me. But now the question is, which line will run before? 11 or 15? Yeah? And this is the controversial part. So Nico and Sule, they thought that 11 will run before 15. But that's not correct. That's not correct. Because line number 11 will need 2 seconds to execute. However, line number 15 will only need 1 second. Because of that, line number 15 will run before line number 11. Yeah? Let's run that and see if this assumption is right or wrong. We start on line number 10, then we should stop on line number 3. Here you go. Then the control should be back to line number 14. That's it. Now we should move to 7. Here you go. And now that's the controversial. Now pay attention, because as soon as I click again the play button, nothing will happen until 8,000 milliseconds. Look. That's it. You see? And now 11, again, if I click again, we'll have to wait for 8,000 milliseconds. This is the longest 8,000 milliseconds in history, right? So now the question is, where is the other one, right? Let's see if we did something wrong, or if there is something wrong with Google Chrome, right? Which it wouldn't be surprising at all. So do stuff 2, set timeout, do stuff 2, callback function. Yeah, that's a bit weird, right? It should clearly run line number 15. It looks like it's a problem with Google Chrome as usual. Let's run it again just in case. 10, 3, 14, 7, Right, now it's not running the callbacks anymore. It's getting even worse. So, as usual, if that ever happened to you, please remember to close the tab. If you're using incognito, close everything, right? Open a new incognito. Again, not ideal, but it is what it is, unfortunately. So now we need to open the snippet again, and let's see if that any help. If not, well, is what it is, right? So at least the console logs should reflect the order, should reflect that do stuff 2 will run before do stuff 1. I hope you agree on that. 10, 3, 14, 7, 11, and let's see if now it stops on 15. Right, it doesn't stop on 15. Did I do anything wrong, guys? I don't think so. I think this is just something awkward of Google Chrome. Anyway, let's ignore the breakpoints, but this is the way it works. Yeah, it's a bit silly when we are unable to run it. Look, now we are not even getting any result. Yeah, that's completely pointless. So again? It doesn't like, yeah, but the thing is, a way to prove that Chrome is right or wrong, because obviously the first time you may think, okay, I did something wrong, eh? But the thing is, if you do something wrong, it should be consistently wrong. That means that if you run the snippet again, without touching anything, it should return the same thing. If you do something wrong, but you run it again, and it returns something different, it's not your fault. Of course, you may have done something wrong, but on top of that, Chrome is miserably failing. Yeah, I would like to one day to talk about, to do a workshop or a meetup or whatever about all the failures with DevTools. Anyway, it's what it is. So that's the way it works. Let me see if there is if I can see any way of continue talking and getting some help from DevTools. So, right, let me open it by the last time. I won't add any breakpoints just in case the breakpoints are ruining the entire experience. Let me run it again. Oh, you see, without any breakpoints, it does work. You see, I'm not going to add any breakpoints because it looks like it's ruining everything. I'll run it again. No, it only works the first time. This is completely stupid. Right. Anyway, I hope you agree that line 15 will run before 11. Yeah? But now the question is, what happens if we want to respect some sort of order? We don't want to invoke do stuff 2 until do stuff 1 has been successfully executed. Yeah? Does anyone know how to handle execution order? Can we do that? Can we move do stuff 2 inside of do stuff 1? Yeah? Look at what we are doing now. So now we first of all run do stuff 1. It may take 1 second, 2 seconds, 20 seconds. We don't care. And only after do stuff 1 has been completed, second of all, we do execute the next function. That's a way we guarantee that do stuff 2 won't run until do stuff 1 is completed. Let me add some breakpoints, which obviously I don't think that will work at all. Right, 10. Yeah, it's missing in the space. The breakpoints are not running, which is, yeah, again, not ideal. Yeah, that's completely wrong. Anyway, how can I explain that if the tool is not working? It's a bit complicated. Let me open it once again, another incognito tab, and blah, 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 yeah? There is nothing else we can do, guys, unfortunately. Right, so snippets, callbacks.
You can use Python
What?
There is another website where you can do something very similar to this one.
Can we add breakpoints on that website?
I think so. You can move one by one. You can
Okay. So what's the name of the website?
Python tutor. You have to set.
Python tutor?
You have to set JavaScript like language.
Python tutor. All right. Yeah. Never done that. Python tutor. Visualize. All right. Fair enough. JavaScript tutor.
Yeah.
All right. What's that? Oh. Okay. So
That's the code here.
hello, and then what?
And then go visualize execution.
And oh, well, that looks a bit complicated now.
There are
Anyway, there's something that needs to be investigated, right? How to?
not for me.
Yeah. Look, now we got a. Ooh. Right, we're getting weird messages on the console. So, right, let me see if now we get any console log. Yeah, you've seen that. So now, hello, even though it takes 2 seconds, you can see at the bottom, it comes first. Yeah, and after running the first function, then we run our second function. In other words, how long it takes to display the first message? Wrong. Why 3? 2 seconds. Correct, Nico. Do stuff 1 takes 2 seconds. And then, how long it takes to display the second message? 3. Correct. 2 seconds because of the first one, plus 1 additional second because of the second one. Yeah? That's the way you coordinate callbacks in JavaScript. Let's run it again to verify it doesn't work anymore. Correct. Oh, no, it does work. Oh, it works again. Right. I try not to touch anything because now I'm not going to add any breakpoint because I may break everything. But you see it works, right? Let me try again. 1, 2, 1, more or less, yeah? More or less. But yeah, it's 2 seconds plus 1 second. Right, so these are callbacks. These are the classic way of dealing with asynchronous code in JavaScript. That's okay. Still in 2019, we still use callbacks. However, they became less and less popular. Even though in the backend, in Node, they're still relatively trendy, in the front end, they look awkward already. Yeah? And it's just a matter of time that they will not disappear. They have some advantages, but in the majority of the cases, callbacks won't be used anymore. Why? Because it makes your code harder to read and harder to manage. You remember the callback hell? Do I have to show you the picture again? Callback hell, right? The indentation, correct, Davide. You remember that? Yeah, lots of, you see on the right hand side, function. This is a bit stressful, yeah, and error prone. At least that code is correctly indented, yeah? But if that code would have been written by some of you, based on your recent experiences on the JavaScript challenges, that will look even worse, right? With random tabs all around. Please look after indentation, guys. It's very important. It's very important. If the code is crap, like this one, at least make it as much readable as possible, given the circumstances. Right, so I would like now to offer you an alternative to callbacks, which are the promises. Promises is a coding technique created by someone long time ago, probably 10 years ago or so, even more than that. It was someone created a GitHub repo, like you can do, and the guy said, hey, callbacks are a pain in the ass, let's try to rethink the way we structure our JavaScript, yeah? So the guy came up with an idea, and he used the word promises to refer to that idea. So promises, so the guy created a library called Q. And that queue libraries quickly became popular across the JavaScript community. One of the main things that happened is in 2011, Angular JS, which quickly became the king of JavaScript frameworks, adopted queue. Yeah? So in other words, before Angular, you had to install npm install. We didn't even have npm install. We had to manually download the script. Yeah? But anyway, you had to manually install queue. With Angular, they say, no, if you use Angular, you get promises for free. Yeah? So Angular massively helped to popularize promises. To the point that starting in 2015, JavaScript, the language, adopted promises. That means that now you don't even need Angular, you don't need to install anything. Anything, JavaScript, promises are there. Yeah? I think it's fair to say that the original proposal of promises are more powerful. You can do extra complex things. But still, I think with JavaScript, you can cover 95% of the requirements. So I think it's a very romantic story, right? Because this is something that came up from one guy. Yeah? Now, interestingly, his library, again, unless you're doing something crazy, you don't need it anymore. He created a very popular library that no one needs. But the side effect is the guy can be very proud because something that he made up is now part of the standard, right? Right, that guy, he won't have any problem to get a job. Right, so let's talk about promises. So I would like to present the same example, but using promises. So with promises, and let me go back to the first one function snippet, we don't need to pass any callback function at all. Instead, we have to do something like that. We need to return new promise. We'll see what that means. And then we have a callback function, interestingly. Yeah? Why? Because inside of this callback function, we can do whatever we want asynchronously. We can do the set timeout after 1 second, or half a second, well, let's put 1 second, yeah? Then now we can finalize our function. How do we do that? Our new promise can receive an argument. The first one is what we call, does anyone know how we call the first argument? Resolve, correct, Vivian, resolve. Why resolve? Because now we can invoke it like that. This is the most simplistic approach to promises in JavaScript. And then how do we capture hello? Look at how readable the syntax is. We can type do stuff, again, without any argument. That's why promises are so beautiful. Because if you pass arguments, it's because you need to customize the behavior, not because you want to capture the return statement. And then, what do we do, guys? Does anyone know?
You have to put a constant.
No. To put dot then, yeah? I'm sure you've seen that, using fetch. Yeah? Fetch embraces the promise API, and that's fantastic, of course. And then, here we got the result. So this is a callback function, so then we can do whatever we want, right? Something like that. So do stuff, take your time, I don't mind, and then once you are ready, give me the result of executing that function. After 1 second, correct. Let's see if it works. It does work. You see? Let's put instead of 1 second, 3 seconds.
I have a question.
Wait a minute. 1, 2, 3. You see? It works after 3 seconds. Yes, book it.
If you remove the set timeout, is it going to respond immediately?
That's a good question. Let's command the set timeout. Like that, right? What do you mean immediately?
There will be no waiting.
There will be waiting. Every time you return a promise, to simplify things, you create a sort of new thread. So that means that even though visually speaking, it will be immediate, in reality, because it will run in parallel, more stuff could run in parallel. Yeah. So that means that if we, for instance, if we put a console log, that is it. I'm not 100% sure if that line will run before that line. And to be honest, I'm 80% sure that line will run before this one. Yeah? Because every time you create a promise, it runs a new thread in the system. Yes, thread with quotes. It's not an actual thread because JavaScript is single-threaded. But it's sort of a new line of execution. Let's run that. I'm right. You see? That message happens before that one, even though this one is immediately returned. But because we're using promises, it runs on a new thread. So just be careful with that. Any questions so far? No? So that's the way you deal with promises. Of course, you can have multiple promises. So again, back to the two method approach. So do stuff 1 returns hello after 2 seconds, and then I'll create do stuff 2 that will return codedy after 1 second. So I'll try to sequence these two requests. I want to call do stuff 1, and afterwards I would like to call do stuff 2. The way to do that with promises, and this is where I hope you can start enjoying the beautifulness of the Promise API, is we could do stuff 1. Say it again?
We could put another line.
Correct. You can put multiple, So you can do things like that. So let me change that a bit. Right. So let me think what we want to do. Okay. Yes, for readability purposes, instead of returning a value, let me put a console log. So console.log returning hello, and then on the second one we'll put console.log returning codedy. Yeah. So I want to display two console logs. Why? Because then we can do stuff 1, then do stuff 2. Yeah, you get the idea? Call the first function, and once the first function is ready, then invoke the second one. So even though do stuff 2 takes half time than do stuff 1, because we are forcing it to run after the first one is completed, it should display after 2 seconds return hello, and after 1 additional second, that means 3 seconds in total, it will display returning codedy. Let's try that. Returning hello, and again our friend DevTools is not helping. So let me try to change the example a bit. Right, let's see if he prefers that one. It doesn't make any difference. Returning hello. Oh no, actually that's my fault. Wait a second. This is my fault. It's not Google Chrome's fault. Does anyone see why do stuff 2 is not executed at all? It's my fault. The code is wrong.
Do stuff 1 doesn't know about do stuff 2.
No, it doesn't need to know anything.
Because you're not
Why? In other words, if I had a break, no, I don't want to have breakpoints. I may ruin everything, right? But trust me, if I would have a breakpoint on line number 9, it will never run. It will run line number 3. Actually, you can see the message, but it will never run line number 9.
We are going now.
Do stuff 2 is not a part of your promise.
because you are not saying then
Then do it.
after do stuff 2.
No, wrong.
There is the return, and you finish with that one.
No.
Stop.
I give you a hint. What happened with that argument?
It's the similar.
We are never ever resolving the first promise. Yeah? Because we are not resolving the first promise, dot then will never run. Because technically speaking, do stuff one takes infinite time. Yeah? Every time you use a promise, you should resolve something. Let me display that. After 2 seconds, I want to display a console log, whatever, no problem at all. But then I need to tell JavaScript, hey, this function is completed. Only after we invoke resolve, dot then will run. Yeah, that was the first and the main problem. So let's run the snippet again. 2 seconds, and then you see after 1 additional second, now it does run our second function. Yeah?
What if instead of resolve we say break?
Break. Here. Break.
Yeah.
But no, it doesn't make any sense. Break makes sense when you want to stop a for loop or when you want to stop a switch. Yeah? But here there is nothing you want to stop. There is nothing, yeah, running in terms of looping. We're just waiting our promise to be resolved. Right?
You can call resolve like rest. You can change the name.
Like rest. Yeah, of course, you can put whatever you want.
Exactly.
Yeah, I can put Walter. Look.
Exactly.
Yeah? It doesn't matter. Very sexy name. Walter is sexy, right? So if we run that code,
Now we break the
you see, it doesn't break anything. That proves the theory, right? That proves the theory. So yes, you can put whatever you want. The important thing to note is the first argument, once you invoke it, then the function is over. Yeah, that's very important. And now we got a question for you. What happened if we want to pass data? Listen, from do stuff 1 to do stuff 2. Yeah, we want to send a message to communicate both functions. How do we do that?
So you pass the data to the result. No?
Correct, correct. Look, let's go back to the more boring but formal resolve naming conventions. So whatever you put here, yeah, hello from do stuff 1. Yeah, you can pass arguments here. And then what? Then look, here, this is what the do stuff 1 function is offering to the world. Of course, we can reuse it here. Yeah? So then do stuff 2, message from do stuff 1. We can hijack, we can connect both methods. Returning codedy. Let's add some message in here. Returning codedy. Do stuff 1 says whatever. Yeah? You get the point? We can pass data from one promise to the next one. Let's evaluate that. So now it will return, it will display returning hello after 2 seconds, and after 1 additional second, it will display returning codedy. Do stuff 1 says hello from do stuff 1. That's the idea. Let's see how romantic this idea is. 2 seconds, and then here you go, it works. Yeah? That's the way you communicate promises. And then, do you remember when talking about intermediate or even expert training, when we have an array of strings, do you remember that we got something like string dot split, and then do you remember we got dot map number? Do you remember that? Yeah? Can we do the same thing here? Look, can we do that? .json? No, this is about fetch. This is completely unrelated. Yeah? You see, that is literally the same as that. So if you only put do stuff 2, once do stuff 1 is invoked, then it will invoke do stuff 2, passing whatever do stuff one is returning. That's exactly the same thing and makes your code a bit more readable, I believe. So let's try it again. Returning hello, and then here you go. You see, it does work. Slightly more readable approach. Any questions? No? Right. One more thing. Promises can be resolved. It means that everything was okay, but they can also be rejected. Yeah? What that means? Imagine that do stuff one receives a number. Yeah? Number, whatever. So if the number is less than 10, we want to resolve the promise. But if the number is greater than 10, we want to reject the promise. If number is less or equal to 10, then whatever, yeah? Else, what? How do we reject the promise?
You need to add the reject.
Correct. Walter is right. When you declare a new promise, the first argument, however you call it, is the resolve argument. But you can put a second argument that, generally speaking, is called reject, which unsurprisingly is another function. So then, if the number is greater than 10, you can reject saying, sorry, the number should be smaller, ha ha ha. Yeah? And now the question is, how do we capture? Yes, because we are invoking at the bottom, then do stuff one, and then we pass a number, right? Number 7, for instance. Then do stuff 2. How do we capture a potential error here? Catch, that's correct. Catch means if something goes wrong, again, we can pass another function saying with a message. Yep. Console.log, oops, something went wrong, and then the message that, you know, our do stuff one is reporting. So let's try that. First of all, should our do stuff one function be resolved or rejected? Resolved, because the number is less than 10, right? Let's try that. So nothing should have changed so far. After 2 seconds, returning hello. After 1 additional second, yeah, returning blah, blah, blah. That's the same thing. However, what happens if I pass 12? Yeah, how many messages will we get in the console? 1. Correct. That stuff will never ever run. It will jump straight to the reject line. And that means it will stop here on the catch block, and it will display, oops, something went wrong, comma, sorry, the number should be smaller, ha ha ha. Yeah? Whatever, yeah, of course, whatever the message is. Let's try that. You see? After 2 seconds, because we are still delaying 2 seconds to evaluate whether the answer is right or wrong, you see, oops, something went wrong, sorry, the number should be smaller. Yeah? So that's the way you can capture. It goes without saying that do stuff 2 will never ever run. That won't be executed because .then will only run if we resolve this function. Because we are not resolving, we are rejecting it, then we jump straight to the catch block. This is particularly interesting when using fetch, which you are already dealing with. Imagine that you want to get a list of TV shows, but you're on your phone, you're on the tube, and you don't have internet. As soon as you try to get the list of TV shows, fetch will fail. So you can capture the error and you can show an appropriate message to your users. Sorry, no internet, or sorry, or whatever, yeah? That's the way you deal with errors in real life, using then and catch. Again, promises, yeah? I understand it takes a while to get used to them, but once you get used to them, it's awkward to go back to callbacks. So the sooner you start fighting and struggling with them, the better. Yeah? There are other usages of promises that I'm not going to explain now, but FYI, for instance, we can run multiple promises in parallel. We can do things like promise.all, yeah, and then we can do do stuff 1, comma, do stuff 2, dot then. So it will run both do stuff 1 and do stuff 2, and only when both are successfully, let me remark, successfully executed, the dot then callback will run. Yeah? So actually we can run this if you want. So I'll pass number 6 to do stuff 1. So then let's display a console log. Console.log, all good. Let's see if we can display that message. First of all, do you think that will work or not?
It sure works because do stuff 1, the number is less than.
Correct. I think do stuff 1 is correct because, as Walter said, the number is less than 10. However, can anyone see any problem with do stuff 2?
Do stuff 2 is already included, not in the stuff 1.
There's no result.
Correct. Nico is right. We are not resolving. That's the problem we had before with do stuff 1. Yeah. So let me get rid of the message because the message is not going to be provided anymore. And finally, remember to resolve it. So now, hopefully, that message will run. How long will it take to run the message? I'll give you 3 options. 1 second, 2 seconds, or 3 seconds. 3 seconds. So why 2, Nico? Correct. When you do promise.all, all the functions will run in parallel. That means that it will trigger both do stuff 1 and do stuff 2 on the first millisecond, and that implies that that console log the time it will take to run will be defined by the slowest function. Yeah? In other words, after 1 second, that one will be completed. However, because that will be still outstanding, we'll have to wait an additional second to display the console log.
All the tasks that we asked to complete and then.
Correct. Let's try that. Look. 1, 2. You see? It clearly takes 2 seconds, not 3. Yeah? And now the question is, what happens if I want to capture what do stuff 1 returns? So do stuff 1 resolves with hello from do stuff 1, and do stuff 2 resolves hello from do stuff 2. How do we capture these messages here? That's a common problem. You invoke the backend, you want to get the data, right? How do we get the data from do stuff 1 and do stuff 2? No, you need another then.
You can put in the function then.
Correct.
You can put like one.
Here, look.
Yeah, argument 1, argument 2, I don't
Not
know.
almost. So when you use promise.all, it resolves to an array of, first of all, what the first function returns and then what the second function returns. So that we call results an array. Yeah. So then we can do result 0.
If you
if you want the first one, results 1 if you want the second one. Yeah? So let's run that. Now it should display all good, hello from do stuff 1, and then hello from do stuff 2 in that order. 1, 2, all good, hello from do stuff 1, hello from do stuff 2. Yeah, that's the way you capture the results. I will strongly recommend you to destructure that array. Do you remember array destructuring? Look at how sexy this is. Then you don't need to access the indexes individually. Yeah? We only destructure the first result and the second one. So if we evaluate that, after 2 seconds, hello from do stuff 1 and hello from do stuff 2. Right? Any questions? No?
You can basically, if you, for example, if you use this to get more data from a server, it is another server or another server.
Yeah.
Once we have all,
Yeah.
then we can manage.
Correct.
what kind of
Correct.
information we want.
Correct. Sometimes your requests are independent. For instance, imagine that as part of the Codery platform, you got your user ID, yeah, whatever it is. And then you want to get, first of all, your details, first name, last name, email, whatever. And then you want to get the scores, yeah, or your position in the rank or whatever, or the player of the day, which is Luigi, by the way. Yeah? So imagine that you have 2 fetch requests, but they're independent. You got the ID, first request, res/details, and second one, res/scores. Yeah? They're independent. There is no need to wait until the first one is ready to call the second one, because that will slow down your application. So you fetch both in parallel, and then and only once you have all the data, you display all the details to the user. Yeah? That's a common usage of promise.all. And I got a question for you. What happened? 2 questions. First of all, result 1, does it refer to do stuff 1 or to do stuff 2? Why am I asking that? Because do stuff 1 is declared first of all. However, it takes longer. It takes 2 seconds. Yeah? So we declare it first, but we resolve it last. So then, result 1. Does it refer to the first function or to the second one? Second one.
Maybe the first phrase is ready. The first they arrive, it will be served for first.
This is a classic job interview question. And let me tell you what the problem is. In that particular case, we're hard coding the time that each function needs to run. The first function takes 2 seconds. The second function takes 1 second. In real life, if you do a fetch to the backend, sometimes do stuff 1 will be faster than do stuff 2, and sometimes it will be on the other way around. In other words, in real life, you don't know necessarily how long a function takes to run. Yeah? Because of that, this cannot refer to resolving time, because that's impossible to determine. Yeah? I hope you agree on that. Because of that, result 1 will always refer to the first element. As Wendy says, it doesn't matter how long do stuff 1 takes to resolve. It will always refer to the first element of promise.all. And likewise, result 2 will always refer to the second element on the array. Yeah? You agree on that? Fantastic. And now the very last question of this extra long session. What happens if I pass 16?
It's gonna break and you don't have a catch.
Correct. In that particular case, will do stuff 1 be resolved or rejected? Rejected, correct. Because of that, again, that's the same principle. Catch. But then, I still got a question, because do stuff 2 is resolved, yeah? And actually it's resolved quicker, in 1 second. So will line number 29 Will that line ever run? What do you think? No, of course not. So then, when using with promise.all, will only run if every single individual request works. As soon as a single request fails, even if it's the last one, then the entire chain is miserably ruined. Yeah? Correct. And the thing is, because promise.all, you know, it's like Walter, hasn't slept 10 hours, is very relaxed, yeah? It doesn't care how long this function takes to resolve, yeah? So even if do stuff 2 resolves first, promise.all will wait until every single request is completed. I say, okay, you are okay, but wait, I need to wait for this guy to see if it gets resolved or not. Because after 2 seconds, that request will fail, that execution will be aborted. In other words, the execution will jump straight to the catch block. Let's see if that's true or not. 1, 2, you see, something went wrong. In other words, the all good message is never executed. And that's pretty much it regarding promises. So, do you have any questions? No? Yeah, of course, you need to rewatch that several times. Yeah, so again, I don't want to say that promises are going to massively replace callbacks, yeah? But at least in the majority of the scenarios, promises are much more convenient. So the sooner you start dealing with them, the better. That was it, guys. We'll do a quick break of 5 minutes and then we'll talk about MongoDB. Thank you for watching.